Set it somewhere there. Yep. Okay, class, let's begin. Let me, this down. This is the study guide, just to go over it, just make sure we got it. And we'll talk about tests as well. Particularly for Matthias.
Oh, no. Yeah.
All right, let's go with it. Study guide for trig. There's calculator or non-calculator, calculator section, and I bunched it all together. That's 6.1 to 6.3. If you can do 1 revolution in radian measurement, 1 revolution degree measurement, and then the one that says all radian solutions, the fun one with the little k values inside them. Seems like it's been in chapter 6 for quite a while, hasn't it? Seems like a long time. Okay, and then from 6.4, just eliminate the parameter t. You should have homework questions similar to that. We're good. And then the calculator section again starts all over again. Bless you. And then it just really is rounding to the nearest 1/10 of a degree. We're good. Honor section, I will give you an application problem in 6.3. And then 6.4, hey, you should recognize this one. This is the human cannonball problem. And then another problem.
Is this still going to be a take-home test?
This will be a take-home test. Yeah.
And when is it due?
That's what we could talk about right now. Let's see. We finished up in chapter 6.
The Monday after.
Have us turn it in. The last.
Yeah, it will be May 31st.
Now let's see. I can probably give it out today.
I feel like it would be helpful to do today homework day and then Monday review day, because I feel like 6.1.
Friday review.
Friday review
I mean,
day?
Friday review day
Mhm.
was like so long ago.
Yeah, I think it'd be helpful to start with that.
Nice. Let's have it Monday.
I agree.
We do.
Yeah, do the Monday after this Monday. No.
You're
So
saying,
do it over
Let's
the
just freaking
weekend.
do it.
you're saying do it over the weekend?
Yes.
How about, let's see, I will give it to you guys on Friday.
I was about to say, I
It'll be
hate
after
you, but
class.
I restrained myself.
And then it's due,
Except for you, you never count.
it'll be due Wednesday, because I don't do it over weekend. Whoever wants to do it before the weekend, whoever wants to do it afterwards, but do Wednesday. We're good? And I'll give you those extra Monday, Tuesday. We'll start on Monday, we'll start chapter 7 if we don't start on Friday. I'll sort of set that up. So whichever homework questions we have. Matthias.
Since it's at home test, will it be due in Google Classroom or in Classroom?
How fun. Yeah, sure. If you can bring it on Wednesday, I'd rather have a physical copy because then I do the physical copy anyways. So yeah, so physical copy back to me. Okay, good there. Let me write that down so I don't forget.
Is there a time limit on the test?
That's the next part here. I would rather you guys take the time with it here. So maybe like a 2-hour time limit, but it's not going to take you that much.
Okay.
We're good. It's going to take you about class time to do it.
And snack in between.
Snack, like go work to have.
Yeah,
That's so weird. While you're
Get up and come jumping jacks, do some yoga, get your nap, good, go back to it.
Too funny. Okay. I'm good with that here. So let's do this here. I want to finish up 6.3 homework. But if we have 6.4 homework, I'd rather have that go first and then go back if we have any here. So let me jam to this. So I really have just homework questions for today. And so let's start off with that one first. Jump to this.
So is there a Google Classroom assignment?
Not yet. I haven't finished it up
I
yet.
never saw it.
Uh-huh. We just had 6.3. We kind of just sort of stopped there. I'll put it in. It'll probably be due by Friday night. That'll be at least fair. All right, guys, real quick here. Any homework questions from 6.4? That's what we're doing. And we'll jump back to 6.3. 5?
29.
29.
37.
37.
We definitely didn't do it.
Yeah, everyone didn't do it together.
I have questions, but I left them more down.
Okay.
Just do all of it.
There you go.
Yeah, just to be safe.
Oh, I was gonna start doing all of them here, sorry.
I mean, if either of you can think of any ones that were hard, then we can go over those, see if you figured them out.
Yeah, I have any stars next.
5, 29, and 37, basically. James and I finish something, I like wipe it from my brain, like, next thing. Always help like an ass. Yeah, exactly.
All right, let's begin. Let's go over it. So graph each plane of each of the parametric equations by plotting points and indicate the orientation of your graph using arrows. Okay. So this is where we got to do this here. It's this little piece. And so this is the t value. This would be the x value. This would be the y value. And then if you want to just put x and y at the same time. And so it is a long problem. So as you plug in, this will be 3 times secant of 0. And we'll put our final answer over here. All right, well, let's jam here. Let's secant of 0. That's no fun because we just don't think about secant. Bless you. Who should we bug today? Oh, Grant.
Whoa.
Secant of 0 times 3.
Wait. You actually have a floppy barrel?
It would be the what? The reciprocal of cosine.
Yeah.
So if you want to kind of do this right here, you can do this. Bless you.
It's just one.
1, perfect, yeah. 1 times 3. In fact, maybe it's even easier just to do secant all the way down, right? Because then you can kind of get into the rhythm of it, and then go back and do tangent here. So pi over 3, 3 pi over 4, pi, and then we'll do the next one on the other list here. Adrian, all yours here. I need pi over 4. So 3 secant pi over 4, but I want to write it as cosine almost. I want to write it like this, just easier.
Cosine pi over 4. Oh, 1 over cosine. Well, yeah.
Reciprocal. So it would be reciprocal of 1 over root over 2.
Yeah.
So cosine of pi over 4 is 1 over root 2. So flip it around, it'll be 3 root 2. Everybody good there?
Wait, it's 3 over root 2 over 2.
3 over 1 over root 2.
Oh,
And then we flip it around, or 3 over root 2 over 2. That'll be fun. Then we multiply like this. We multiply, let's see, let's do it faster here. So this one would be 3 multiplied by the reciprocal of this. That's what you were saying, right? It makes 6 over root 2. Then we rationalize the denominator by multiplying by root 2. It makes 6 root 2 over 2 and eventually 3 root 2. Whew. Okay, so real quick here in trigonometry, sometimes it's easier to use that one. Sometimes easier to use that one, depending which way you want to end. We good? In this case, since you are going to take the reciprocal each time, easier to do that one. Okay, so let's see. Let's get, let's see, square root of 2 is about 1.4. So we need to multiply that by 3 since we're going to be doing that a lot. So how about 12? How about 4.2 approximately? Tell me if you guys agree. No, don't agree?
Wait, what?
Sure. So square root of 2 is approximately 1.4. And then we're still gonna multiply by 3. So 1.4 times 3 is about 4.2 for graphing purposes. So we got about 4.2 there, and I guess that will repeat itself quite a bit. So let's jam with it here. So 3 over cosine of pi over 2, Matthias, all yours.
The pi of, the number is the which one?
Yes. Cosine of pi over 2.
No, who wanted to win in the house?
Literally my internal monologue.
My hypothesis is, what?
To
Oh
summarize.
my
Cosine pi over
What?
2 is 0, right?
Yep. I'll give you a hint though. Yeah, cosine of pi over 2 is 0.
I agree.
Obviously.
2 page long book.
So,
And then your thesis statement. In
Two.
summary, what?
2, how about Matthias? How about
Weird to have
undefined?
undefined there.
Yeah.
Yes, I did that.
That's what I was
Yeah.
trying to say.
Yeah.
Cosine 3 pi over 4.
So in a way, he is right.
What? Yeah. Uh-huh.
I'm not defining the
variable.
answer to the thing,
You don't know.
The
It's just
answer.
undefined. Zechariah, next one. We'll pass on Matthias. Let's see. That would be like pi over 2. Grant, Adrian. Cosine of 3 pi over 4. That would be still 1 over root 2, right? We flip it around, except it's going to be a negative this time. Everybody good there? So just kind of thinking back. This is unit circle. Hopefully have it in front of you as you do the pi over 4s. These guys are going to be root 2 over 2 or 1 over root 2. It just depends if it's a negative or a positive. So those will be negative in these quadrants. They'll be positive in quadrants 1 and 4. So I'm going to go with a negative 3 root 2, which just translates to a negative 4.2. Pi would be,
Wait, how did it translate to a negative 4.2? Oh, because
It's just the negative version.
Yep.
Georgia, all yours for this one. Ah, shucksaroo. Let's see, cosine, it would be right over here, so it'd be negative 1, 0. So it should be negative 1. There, be okay with a negative 3. Cool. All right, then.
It's almost like a battery.
Whoa.
Maya, are you okay with the negative 3?
No.
Fine.
So then do we only have to go to pi?
Essentially, yeah, as long as you can kind of figure out the rest here. This would be 5 pi over 4. The rest should be a repeat here.
So is it possible to solve these without drawing the table? Like, can you mentally, or if like you're looking at a past table that we've done?
Uh-huh. Let's see, a past table might help you. Mhm.
Probably would just complicate it.
See, the fastest way to do it is instead of going by pi over 6 and pi over 3, we go by pi over 4 because it gives us those 45-degree angles. And it gives us the same number each time. That's one sort of easier way to do it. Then you get the 90, 180, and 270 angles. And based upon those, we try to figure out which way we're going with it. At least that should give you a sense of direction with it. And so this one, again, 3 over cosine 5 pi over 4. That is going to be in quadrant 3. So you know it's a negative, again, negative. So negative 3 root 2. So negative 4.2. Grace, all yours for this one here. Cosine of 3 pi over 2.
I'm still writing down the other one, but I also don't have my book and I'm not sure.
Cool. I'll erase it as we go here. So it should be right here. So it should be that little dot that we know.
Yeah, I think you're right.
Since we're going straight down, this should be 0. That's the one we care about now. So undefined again. Cosine is 7 pi over 4. Ooh, that's going to be positive, huh? Nicholas, all yours for this one. See if we can do some mental math here. This would be, again, this little 1 over root 2. It's a positive this time. So flipping it over. That right there. And answer on this side. Actually, you don't even need to do pi over 2 because it's going to go back to the original problem if you do 2 pi. Nicholas, I'm thinking positive 4.2. Good. Okay. Okay, got the x's taken care of. Let's go back over here. You'll see the tangent's probably easier to do. So hopefully you have it in front of you here. Amaya, I have this right here. 3 tangent of 0.
So just be 0.
Still be 0. So tangent, let's go to tangent here. Let's think about this one here. Along the 45-degree angles. 1, 0, 0, 1, negative 1, 0, and 0, negative 1, right? For the 45-degree angles, even easier. It's going to be a ratio between x's and y's. In this case, the 45 is going to be 1. That'll be negative 1. That'll be a positive 1. And that will be a negative 1. Everybody agreed there. That's the ratio between 3. So tangent actually should be a lot easier. Haley, all yours for this one. So 3 tangent of pi over 4. Just 3, I like that, just 3.
It's just like, this one will be easier. And it's just like, really? Is it gonna be easier?
I don't trust you. Right, Lynn, all yours for 3 tangent of pi over 2. It's going to be sine over cosine, right? So sine over cosine, bummer. I got undefined. We're good.
So both of those points are undefined.
Mm-hmm. See how that works out.
Just coloring the whole graph, like it could be anywhere. We're not really sure.
Wait, that was for pi over 2?
Pi over 2, both undefined. 3 pi over 4. Corinna, all yours there. This would be 3 times negative 1. Y is equal to 3 tangent of pi. Hayden, all yours there. And it's going to be here. The tangent is, right over here, tangent is sine over cosine. 0 over negative 1. Still 0.
Negative 0. Whoa.
Wait, that one was 0, right?
That one was 0. Or in Adrian's world, negative 0.
Yeah.
Grant, back to you here.
Yeah.
Tangent of 5 pi over 4. Let's see if you listen to the
Almost maybe one.
1, so times 3. That's cool. Okay.
3 is negative.
Adrian, all yours here. 3, 5, or 2. Undefined again.
So what happens
Interesting.
if you get one of those points and one of them is undefined, but the other one isn't?
We cried.
Yo,
Because we have information, but we
Uh-huh.
can't put it down, because we don't have the full set.
Does that just turn into a line? You're probably wrong.
No,
mine
Yeah,
just
it
you
shouldn't.
know exactly where it is according to one coordinate, but you don't know where it is
Yeah.
on the other coordinate, so that is like a line. I mean, it wouldn't be, but, I mean, probably not.
No, yeah, because notice on the homework here, sine goes with cosine. Notice that secant goes with tangent always, right? Because that is, because it does make them both undefined. So there's let me just check here one more thing here. So there is a understanding of things here, because secant and cosine will give you a hyperbola. So you always go with secant and tangent together. In fact, there's never a time, as I was looking at them, there's never a time where secant and tangent are not together.
Okay, but what if you wrote an equation where secant and tangent are not together?
Sure. It would be undefined. You would not write it down.
There's just one to do.
It just doesn't exist.
Yeah.
Mathematician would come and be like, no, you can't stop.
Switch it here.
Switch.
Matthias.
They kick you out.
It's not a what again?
If you're
Is it a
college
negative
and you do that.
-3, awesome.
I'm so smart.
Okay,
Well, that's just-
can we put these all together to one graph here?
Yes.
Let's see, the highest I go is 4.2. The lowest is a -4.2. So I'm going to build my graph maybe out to 5. 1, 2, 3, 4, 5.
Yeah. Knows. He's ready.
All right, I'm going to go back and forth between graphs here or slides here. So 3, 0, done. 4.23. 4.1234, 4.2, 1, 2, 3 is about right there. Okay. Undefined, so we're not going to graph this one. No need to graph this one. Then we have a -4.2, -3. 1, 2, 3, 4, 4.2. 1, 2, 3, somewhere down here.
So we just skip the undefined ones.
-3, 0. -3, 0. -4.3, +3. And what undefined does for you is you don't have to connect one to the other. That's essentially what you do there. Let's see, undefined and defined, and 4.2, -3. So let's see how this works here. So the first one,
That's a weird looking one.
Oh, yeah.
Was for 5 pi over 4, that was -4.2 and,
So.
wait. there-
-4.2, +3.
Oh, yeah, so I remember 1, where did that come from?
All right, let's see how it works here. So this one was the first point, right? It comes up to this point here. And notice you have the undefined term. So at that point, if we were to graph more and more pieces here, what would happen is we would go further and further out. And so at this point, you go this way and it'll go that way. What happens here from this point here, the undefined terms, it says really that I don't connect this point to this point. There's no connection between the two. There's a break there. So I can start over. So then this point here connects to this point and then connects to this point and then again starts over. And if we were to graph pi over 2, that point would connect back to the original one. We're good? So you got two, in a sense, discontinuities or two breaks in our graph. And the reason why it looks like a strange ellipse, Matthias, is because it's a hyperbola.
Yeah, it's just.
I was being stupid on purpose.
Totally understand.
I'm sure. That's like how I always.
I've been a bad person.
No. I don't think I will.
Cool.
Wow.
Okay, fun little story.
I know.
For eclipses, hyperbolas go the other way, and hyperbolas, let's see, do they? Yeah. They are kind of backwards ellipses, right? Except they go out to infinity on the sides here.
What's an ellipse? I don't.
Ellipse is,
What, like ellipse on-
I can think of it in my head.
Yeah.
So the opposite of this.
that's an ellipse.
Oh, you mean an eclipse?
Oh, yeah.
Right.
Right.
So is that hyperbola?
The thing in
I
space.
think I know what an ellipse is. It's when the ellipse-shaped object in the sky called the moon, like.
Right.
Oh,
Oh, that for the light is
Yeah,
off,
it's
yeah.
probably named because the
Did you
moon
just
is
say the
technically
moon
an
was
ellipse.
shaped?
You're right. Yes, yes.
Oh, wow.
Too
Boy, Adrian,
funny.
you're so right.
You're right.
I never
He was
realized.
literally right. I don't know what you're talking about.
Anyway.
I don't know. So, let's go with it.
It is literally
Um,
an ellipse.
Lord.
Oh, so it's like a flipped inside out. I see what you mean.
Yeah, it's kind of flipped into that, except the hyperbola goes out to infinity on the sides.
Right.
Oh.
Interesting thing.
That's if the moon was hyperbola shaped.
Okay, okay.
Okay. The interesting thing about an ellipse, Is it? Yeah.
I think you're on a different.
guys, real quick here, let's go. Is the fact that if you were to string a line, and these are called the foci right over here, because each one of these guys have foci.
I remember these, I hate these.
If you put a string together and keep it the same length, right, you would actually draw out the ellipse each time, right? Because that's
You
the
mean like
that's
if you drag that along the edge?
Yeah.
so that's how an ellipse is formed. In fact, that's how the Greeks used to form the ellipse, where they used to put the foci and then you just have a string that
Did we do that?
that
Oh my God.
Yeah, we
etches
did.
out each time. That's cool. Let's see. The interesting thing about a parabola, yeah, or I think it's a hyperbola. Yeah, I think the one that we just did here is the fact that the foci. What happens is when you have something that comes in straight into it, it bounces and it gives you the foci. So anything like that. That's why satellite dishes
So you
are
can
made.
still kind of do the
Oh,
same thing
yep,
along that edge.
yep.
Mhm.
Right there.
So satellite dish always has this, right? And then it has a little kind of receiver that's kind of attached to here, right? The reason is because all those transmitted rays jump into here.
That makes sense.
Long time ago,
That was just like curves, so they just made a curve shape.
long time ago, went to a theme park and let's see, they had this hyperbola shaped thingamajiggy. It was maybe about 2 feet tall. And they had this little ring right here. And then on the other side of the park, it was maybe what, 50 feet away, I guess, right? They had the same one on this side right here, like this. So then, this is when my daughter was like 4. This was 15 years ago. I would whisper into this little thing right here. And then 50 feet away, she would hear me whisper on the other side.
Whoa.
Like, we're so fun to control.
Yeah, and that's how like, Capitol, isn't that like how the Capitol building was specifically designed to eavesdrop? Like,
Oh, interesting. I didn't know that.
yeah,
Yeah.
I remember that like.
Adrian is full of.
I just remember that I had to memorize this. Trivia so much about the Capitol. I was reading. Like this was homework last year. For some reason we had to learn about that. Because if you like whisper into one part of the dome, you're like, are you sure?
Goes to the other side. Yeah. So it's shaped as a hyperbola on both sides with foci somewhere in there. So you have to be standing in a certain position
Yeah.
in order
that's
to
it,
hear the
yeah.
other side. Okay. All right. Well, let's jam here. 2937. Hopefully we'll get through here. 29. Did I assign 29? Yeah. Okay. I just don't have it. I just don't have it circled. That's why. So y is equal to sine of t. Okay. Let's go with it here. Limit the t in each of the following.
Wait, no, I feel like I think
Let's
I know
already
how
solve
to do
for
it.
x.
Oh, this one we solved, we just didn't know why.
Yeah.
How'd you guys solve it?
I got 1 minus 2 y squared equals x.
Squared is equal to x, something like that. Cool. Mm-hmm. Okay, so let's see the relationship between the two. The easy one was the fact that you could just change it into cosine squared t plus sine squared t
Is it?
is equal to 1.
Oh, wait, never mind.
They got this little 2 thing in there, right? That's what makes it not so fun. Because this one will be directly plugged into here. That's nice enough. This one, not so nice. But let's see, we have 3 different options here, right? Because go back to your notes or anyone that has this. Is there a double angle formula for cosine? Like in your textbook, something like cosine 2 theta.
It's, well, yeah, which one of the equations?
Yeah, there you go. Which one of the equations? So because it's an x value, we're going to try to keep it as cosine anyways.
Okay, so then it's 2 cosine squared, it'd be t minus 1.
Let's see, cosine 2 theta is going to be the same thing as 1, 2, or is it 2? 2? 2 minus?
It's 2 times cosine squared theta minus 1.
Gotcha, okay. So connecting this together to 2 cosine squared t minus 1. Good there? And we're still Sure. Let's go back over here because we're trying to figure out how to get it into a connection between cosine and sine. And so the only connection we have is that we know that cosine squared theta plus sine squared theta is equal to 1. So any which way we can sort of set those in. In this case, instead of theta, because we don't care what those are, we want t instead of here. Because what's going to happen is we're going to put it in terms of x's and y. So notice that sine t is going to fit right over here. That is solved for. That is great. It's just going to be y squared right there. So I have that one solved. I can get it back into just in terms of x's and y's. Cosine 2t, not so fun. So we use the double angle formula for cosine.
Wait, so you turn the sine squared t into y just?
To get rid of t values. So,
Oh, and because it equals y.
So in this case, we are going to try to figure out how to get rid of this one here. So let's see, I'm going to add 1 to both sides. Bless you. Cosine 2t. Notice it's already squared though. That's kind of interesting. So divide by 2. So I have this x plus 1 over 2 is equal to cosine squared t, which is exactly what I was trying to. I was trying to. So x plus 1 over 2 gets substituted. Notice now I don't have any t values. So I went from parametric equations back into functional equations. So in this case, let's see, I'm going to multiply everything by 2.
Oh wait, yeah, that makes sense.
That'll be 2y squared, and that'll be a 2 on that side. And then just depending which way you want to write this here, I'm going to subtract 1 from both sides. So minus 1 gets me x plus 2y squared is equal to 1. And I'm not sure if the back of the book wants to subtract 1 from both sides, make it set equal to 0, or is it, there will be a parabola at this point.
Yeah, so do they want, because this one was set x equals, but why would they set it to that?
I don't know. They just wanted to put it in some kind of form whatsoever.
No.
So just depending which form
No,
you
they
want
just-
it in.
They just hate 2y squared.
This one.
We just want to just subtract that, yeah.
Any one of those are right, as long as you have a relationship with x and y. That's the whole point here. So the back of the book has it like this. Is it negative first or 1 first? 1 minus 2y squared. Who cares? Any one of those are correct right there. Cool.
Oh, wait, maybe I guess now.
Bless you.
29 is good?
Yep.
Jam to 37. This is the human cannonball fired from a cannon initial velocity of 50 miles per hour. On the same screen of your calculator, graph the paths taken by the cannonball if the angle between them was 20, 30, 40, 50, 60, 70, and 80. Okay. So
Is
first
it
things first.
37?
First things first, we got to get 50 miles per hour into feet per second. That's the only.
Wait, for some reason, when I did 37, it said maximum height, maximum distance,
Yeah,
and
that's
time.
what it said.
Okay, if I'm reading 28, sorry.
I was
So
like,
Oh.
let's do the real 37. So it says example 5. It says graph the parametric equation example 5 and then find the maximum height of the cannonball, maximum distance traveled. Okay, so that's cool. Is it still 50 miles an hour or no?
It is.
I think it's the same.
Yeah, still
I
50 miles an
assumed it
hour.
was the same conditions.
At a 60-degree angle. That's what example 5 is. Okay, so let's go with it real quickly
oh,
here.
it's still that.
Still the same thing here. So 280 feet per 1 mile. We have, what's the next thing? Hour goes in seconds. So 1 hour, 60 seconds, 60 minutes. Have a very fast hour. And 1 minute gets me 60 seconds on a calculator. Anybody? I just want to make sure my units are correct here. Yeah. Anybody on a calculator, give me that. What is that? Nearest tenth or so. 50 times 5,280 divided by 60 divided by 60.
Is it 73.3?
Okay. Second, that's cool. Okay, so then I have my x coordinate is going to be 73.3 times cosine of, okay, just 60 degrees, right? Times t. The y value is 73.3 sine of 60 degrees
Wait,
times
where did you
t
get 60 degrees from?
from example 5. It says at an angle of 60 degrees from the horizontal. Okay, 2 equations, a little bit of time to get there. So let me go to geometry. Let's go. Let's see. Got to go into degree measurement first of all. Degree measurements. Next, parametric equations. Next, done. There's my mode change. Next is t, and then tell me if you need me to slow down. Oh, you know what? Hold on. Let's go back. Got to put a parenthesis here because all of this is multiplied by t. So 73.3 cosine 60 degrees. Close off the cosine, close off the whole entire value times t. Enter. 73.3 sine of 60 this time. close off sine, close off the whole entire thingamajiggy times t minus 16t squared. Okay, so it should be those things right there. Let you guys catch up. Then we have to think about our window. Cool. Okay. Let's see, we're gonna go from here to here. I don't know how many seconds it's gonna take for him to, so he might go underground again. We'll see. This would be what, -10? I want to just
What
gonna
did you
guess.
enter in for the T-max?
Tmax is 2 pi,
Okay,
and that's just my regular one,
yeah,
and it
What
could
is
be,
the- My T stuff is different.
yeah, mine was,
Oh, it's just double that.
Mhm.
So
So is that pi over 12?
Yeah, it doesn't really matter because we can connect it. It's just how many pieces connect to it here. So pi divided by 12, I think that's what I had there initially. Yep. Actually, I had pi divided by 24 just to give me more values, that's all. Okay, -10. And let's see, last time we did this here, we were like at 250. So I think I'm gonna try 250 across the horizontal. Let's see if I need to zoom in that way. And every 10. Y minimum, -10. I'm gonna go up to 100 just to sort of see initially. By tens, okay. That's my initial one, just guessing. Guessing from Monday's class about how this might work out. Okay. Are we totally off on the window or okay?
we're pretty good.
We good? Oh, cool, okay.
Ah, I know. Mine is just like over here, like, boop.
Are you in degree measurements? Degree or radians? In degrees? Okay. Those of you that have the graph, tell me maximum height,
I'm in degree.
horizontal distance traveled, and then the time it took.
Here's my graph.
you zoomed in, right? You hit trace.
Oh my god. I literally hit table thinking it was right.
Trace.
The maximum height 64.7 or 63.8, I guess.
That's what I got.
Mine is like shrunk down now, but maybe it's like shrunk
So
and
that's the
squished.
maximum height.
I think so.
Maybe it's the way my graph is.
Maximum distance. This is where
But I said
I
it's-
Whoa, what just happened?
Either that or like.
I want it to be back to normal. How was it before?
Down through my abdominal cavity.
Grace, we'll get there.
My thigh. Can't see that. So I'm assuming it has nice.
Why?
little
I
window.
didn't put the country.
Aha.
No, I don't actually have blood.
Wait, how do you do?
Right,
Oh,
yeah,
that's
yeah.
just the
All of your organs are
Yeah.
good, but no blood. Yeah, just sand. Exactly. I am dark sand.
This is when I can't remember what to do.
You go to table.
That's what I'm wondering.
No wonder why dark sand can be killed by a lightsaber in this term of class.
You are doing some funny stuff here.
What?
Oh, there we go.
He's impossible to
The closest I could get was the
Except for Sam.
3.9
You got a second one.
thing.
Oh, I didn't see that.
And a square and a square.
Maybe now you go to table.
Third time's a charm, Grace. We'll get there.
Wait, how do you delete it again? How do you delete something? I never,
Uh,
I always have to clear them.
Should you have to shift to the.
Wait, so it's from Y to 0.
And 3.9.
That's why you should. That's why you should be real.
Maybe.
You imagine?
It's
That's why you should
around
be canon and you can turn people to the dark side better than Palpatine can. Yes, why? Because the only way to defeat him is to use Sith lightning. Yeah, if only they made Darth Vader canon.
I'm gonna guess it's
I agree. I agree.
It's just too, yeah.
Apparently, the force is like an actual religion.
Yeah.
Like it
Yeah,
was listed as one of their actual.
yeah, the religious survey where when people said they were Jedi.
Yeah.
Nice.
How about this? Let's try this one.
That's awesome.
Most of that probably doesn't mean they like actually.
No.
I don't know, there seems to be
Uh-huh.
a force in
This
the
is
world.
England we're talking about.
Yeah, you're expecting English.
I
people
forget how to get it to go
Don't you
like
think English
directly on
people-
here.
3.96 is the
You're
closest
expecting
that I
English
found
people
for
to
T value.
Oh, yeah.
Yeah, so it's like 145.1.
I'm sure that.
Wait, how did you get American?
I went to the trace thing and I just
No,
put it
American people
until it
would
was
say a lot of
as close
worse
as I could
things.
get. And then found
Or American
how
people-
it was T value, and then went through the table and tried to find the T value.
That would be
that
the
was
least.
closest.
I mean,
Yeah, exactly, that wouldn't do that.
Class, real quick, let's finish up. So the height, so this would be the trace button right here, is that right? And then you just go up here to the highest height. And notice it has like a little bit of a straight line right here, right? There's a point in which when things go up, it stays at that little height, right? And it comes back down. And so that's kind of nice for us. So just click somewhere close to that. Is that close there for the height? Yeah, we're dealing with either a 62.6 or a 62.7, right?
Yeah.
Somewhere right in that range. And so for our purposes, putting the higher one of the two is just fine. All right, with 2 minutes left here, let's see, how do we get the zero value there? So that's one. Second one is going this way. Ooh, it dipped down. There it is, right before it's the ground. We're at 4 feet high. Oh, no, 4 seconds later, right? We're at 2.5 feet high above the ground. So what we do just to get a more specific, right, value, we're going to go to table. We're going to see if it hits the ground here. And we can specify that quite a bit here. So let's see. We are going to start off at 3.92 or 93 along our T value.
Yeah,
We're
the
gonna keep on
closest
going
I
down.
could get was 3.96, and that has a 0.47386.
Okay. That's cool. So we'll go to
Wait, so
table
for-
set.
Wait,
It's
wait.
above.
In table, how do you change just the T down here to get to it faster?
Yeah. I have 3.9.
Let's see. We got to go. So there's a table. There's a table set. This one you have to do first. It's above the
Okay.
window marker. So go to table set first,
That-
and then we have, help me out here, 3 point what? 3.9. And we're gonna go every, I guess, 0.001. We can do it that way. Or 0.01? Sorry, that would be too small. Sorry, 0.01, just the hundredths place. And this should be auto and auto, because we only have one thing graphed. Now let's go to table. And then let's keep on going. And we're looking for the Y value going down to 0 or close to 0 here. So we go down.
Closest.
Oh, it goes negative now.
Yeah.
Yeah, because the
Mhm.
closest the Y gets is negative 0.16.
Yeah, that would probably be the closest one. This one is 0.5, so half a foot, right? This is negative 0.16, so that's 3 inches high. That is pretty close. So horizontal distance is 145.5. The time it gets there is 3.97 seconds. Are we good?
Oh, so the time is just the timer.
Time, So you get the T value by the table as well.
Wait, so would you go for the one that's negative or the one that's positive?
I'd go for the one that's the absolute value closest to 0.
Okay.
Oh, wait, sorry. So the thing that we were writing down, the height was 62.7,
Mhm.
and then we were, what was the next? one?
Horizontal distance is 145.5. It's the X value. And the time it takes to get there is 3.97 seconds. And we are out of seconds for this class, so we're done. Okay, I still need to give you guys homework for 6.3, so that shall be done sometime. We good? But talk to me here. Are we good with homework for 6.4? We still have to do some more.
That was good for me.
I don't remember, but I was kind of home, so.
Okay, sounds good.
I have a feeling
So-
lots of people do it there.
Yeah, I think.
Yeah.
Yeah, I'm done.
Sounds good.
You're
Okay.
wrong. Say if the launch didn't work, you can no longer do a parabola.